Bismillah Rahman Rahim. I am Muhammad Ehsan Chatta, Assistant Professor, Government Degree College, Jharkhand. Dear student of the second year and BSc class, today lecture is about valence shell electron pair repulsion theory, also known as VSEPR theory. Valence shell electron repulsion theory is used to predict molecular shape. Number 2, name the 6 basic shapes that have no unshared pair of electron. Valence electron pair repulsion theory and molecular shape. Lewis structures show which atoms are connected where and by how many bonds, but they don't properly show 3D shape of the molecule. To find the actual shape of the molecule, first draw the Lewis structure. And then use the valence shell pair repulsion theory. Valence shell electron pair repulsion theory or VSEPR theory, molecular shape is determined by the repulsion of the electron pair. Electron pair around the central atom stay as far as apart as possible. Electron pair geometry. Electron pair geometry is based on the number of the region of the electron density. Consider non-bonding lone pair as well as the bonding electron pairs. Electron pair in single, double, triple bond are treated as single electron clouds, yani single pair. Molecular geometry based on the electron pair geometry. This is the shape of the molecule. Electron group repulsion and 5 basic molecular shapes are given here: linear, triangular, planar, tetrahedral, similarly trigonal, bipyramidal and octahedral. Square planar geometry are given here. The single molecule shape of the linear electron group arrangement. If there is the central atom is surrounded by two bond pair of the electron, as in beryllium fluoride, carbon disulfide, hydrogen cyanide. All these molecules have the two pair along the central atoms. In beryllium is the central atom, fluorine is both sides. In carbon disulfide, carbon is the central atom, sulfide is on both sides, but double bond consider only one pair. Similarly, in hydrogen cyanide, carbon atom is central on one side, hydrogen one pair, and on other side with nitrogen triple covalent bond is considered also one pair. So HCN also have the linear geometry. The two molecular shape of the trigonal planar electron group arrangement. If there are three bond pairs, then they form the exact triangular planar geometry, as in case of BF3, SO3, when there is two shared pair, two bond pair and one lone pair, then when they are placed in three dimension, on one side lone pair, on other side two bond pair, then the bent V-shaped geometry is formed. In case of sulfur dioxide, in case of you have a 10 bromide, all 10 chloride, stannous chloride, all these molecules are band shape, their angle 118 degrees centigrade. Their angle is between the two atom is 118 degree. Factor affecting the actual bond angle. The bond angles are consistent with theoretical angle when atom attached to the central atom are the same, and when all the electron are bonding electron of the same order. For example, the idea is have taken is here as formaldehyde. In formaldehyde, carbon is attached with two hydrogen that are at angle 120, while similarly oxygen is attached, it is also as 120, but oxygen has double bond, it is considered as single bond, but it also lone pair, greater electron density, greater electronegativity. Due to greater electronegativity and lone pair, the real angle in both hydrogen is will be decreased by the two times in 120 less than 4, and that is equal to 116 degree as in formaldehyde, both hydrogen and carbon. So the hydrogen and hydrogen, carbon and oxygen angle is more than 122 in 120, and it is 122 degree. Factor affecting actual bond angle. Lone pair repel the bonding pairs more strongly than the bonding pair repel each other, as in 10 stannous dichloride, stannous chloride. 10 has one lone pair and two bond pair with chlorine. Chlorine are placed at angles 120 according to triangular planar, but due to repulsion of the one lone pair, the chloride come close together and angle reduced to 120 to 95 degrees centigrade. So the stannous chloride have 2 chloride and 10 angle is 95 degree. The three molecular shape of tetrahedral electron group arrangement. Tetrahedral geometry CH4 4 bond pair, all they are exact tetrahedral, one angle 109.5 degree. Silicon tetrachloride also it have the exact one angle 109.5. Similarly, all they are tetrahedral geometry. Ammonia PF3, Cl3 and hydroxonium, all they has the three bond pair and one lone pair. Due to three bond pair, it is tetrahedral geometry, but due to repulsion of the one lone pair, there is angle is reduced less than 1 109.5 to 107.5. This geometry is known as trigonal pyramidal geometry. Trigonal pyramidal geometry. Similarly, in water, OF2, SCl2, it is also have a four pair geometry tetrahedral, but there are two lone pair and two bond pair. Due to presence of two lone pair and two bond pair, lone pair two occupied two tetrahedral corners, they more repel each other. Due to more repulsion, the remaining two atoms, their angle reduced to 105 or 104.5. Then its geometry is V shape or bent geometry. The four molecular shape of the trigonal bipyramidal electron group arrangement in this PF5, it is triangular bipyramidal geometry, arsenic pentafluoride, SOF4, all they have the same geometry. Similarly, when one lone pair and other four are bond pair, as in SF4, I4 positive, xenon dioxide difluoride, all they have the geometry just seesaw geometry like similarly, in if there are two lone pair and three bond pair, then geometry is just a T-shaped geometry, as in ClF3, BrF3. If there are three lone pair and two bond pair, as in xenon difluoride, triiodine, IF2, the linear geometry will be found. Three molecular shape of the octahedral group arrangement. In this case, SF6, IOF5, all have the bond pairs. There are seven bond pairs. These are octahedral geometry. If there are five bond pair and others six is the lone pair, then the square pyramidal geometry, as in BrF5, TEF5, and xenon oxytetrafluoride. Similarly, if there are four bond pair and two lone pair, xenon fluoride, XeF4, ICl4 minus 1, all they have the same type of geometry known as a square planar geometry. Let us review the valence electron repulsion theory. Predict the molecular shape of the bonded molecule electron around the central atom. Arrange themselves as far apart from each other as possible. Unshared pair of the electron lone pair on the central atom repel each other most. So only look at what is connected to the central atom. Let us consider few more example. Linear geometry, AB2 type, beryllium fluoride, and similarly you have a second group, boron, beryllium, all they form the linear geometry, and aluminum, these are the form triangular planar geometry. Carbon dioxide. Carbon dioxide has two oxygen with double bond, and double bond is considered only one pair, and so carbon have two pair on both sides. The linear geometry of carbon dioxide shown here, carbon with black color and oxygen with red colors. Trigonal planar geometry, bond angle of 120, 3 atom attached to the central atom and lone pair 0. Example AB 3 types of aluminum fluoride. It is triangular planar with angle 120. Boron trifluoride, fluoride atoms shown in the green color, while boron atom is shown with the dull brown colors. Tetrahedral geometry in AB4 types with angle 109.5. All are bond pair. The shape is CH4 carbon tetrachloride. carbon atom is black in the center, while R 4 carbon atom with green color. Similarly, in carbon tetrachloride, all chlorine atom also with a green color shown. Trigonal bipyramidals, 5 atom attached to the central atom, 0 lone pair angle 120, and axial angle is of 90 degree. AB5 type, example phosphorus pentafluoride. Central yellow colors to ball represent the phosphorus, and all the gray ball showing the fluoride atoms. Trigonal bipyramidal geometry, antimony pentafluoride, SBF5. SBF5 in SB represent where the dark brown or red colors, and fluoride atom with green color. Geometry जो है वो is trigonal bipyramidals. Octahedral geometry, there are 6 atoms attached to the central atom, 0 lone pair, bond angle 90 degree. The consider in AB6 type, example is SF6, sulfur hexachloride. Sulfur atom is shown in the blue color, while red जो है वो shaded atoms are of fluorine atoms. Sulfur hexafluoride shown here, in which there are fluorine above and below, and 4 fluorine are in the square planar, so 4 corner of the square. They have the angle fluorine into the fluorine, which is in perpendicular to each other. They have 90 degree, while other angle is 156.4 picometer. Distance of the bond from the sulfur to the fluorine above and below. Boron trifluoride shown as earlier explained. Bent geometry of the sulfur dioxide. Sulfur dioxide had double bond with 2 oxygen atom, so its angle 2 जो है वो bond pairs, and 1 lone pair is present. Lone pair repel the 2 oxygen atom more, so angle is less than 120. Carbon tetrachloride, exact 4 bond pair. It is tetrahedral geometry with 109.4 degree angles. Trigonal pyramidal geometry, it is ammonia geometry with 3 bond pair and 1 lone pair. Lone pair repel more as compared with the bond pair, so we get the trigonal bipyramidal geometry of the ammonia. Nitrogen trifluoride, it is also geometry is trigonal bipyramidal, but due to more electronegativity of the fluorine electron are more exposed, so angle of the fluorine due to repulsion and electron pair repulsion and fluorine more exposed electron, and जो angle between the 2 fluorine atoms in NF3 is reduced to 102 degree. Bent molecule water, it have 2 lone pair and 2 bond pair. The bond pair are arranged at angle 104.5. 2 other corner are occupied by lone pair which repel the bond 2 hydrogen more forces. Chlorine difluoride ion is a bent type geometry as shown in fluorine is 2 lone pair, and other 2 places are occupied. They have very small angle as compared to bent angle. T-shaped molecule, chlorine tribromide, it have two lone pair and three bond pair. Two lone pair repel more, so that it is just like T, in which a central atom, oxygen central atom, which is represent the green color, which is of the chlorine, and three bromide atom with green color are represented here. Thank you, student. Allah Hafiz. See you next time.